Okay, hello everyone. Madam Lee is going to go through example 3 part C because part C is a bit more complicated than part A and part B. Okay, and to do part C, I would assume that you have already found part A and B because we are going to have to use hence, which means the result from part A and B. Okay, so to understand the question, they require you to find the fraction or the ratio linking OAX, which is here, and OAB, which is the entire triangle. Okay. So for the entire triangle, and OAX, we will now think about which case this two triangle belongs to. Is it the similar triangle situation? Do they share a common height and common base? Or the last case where they share a common angle? So if you think about these three cases, it seems that definitely they are not similar. Definitely they do not have a common angle. Okay. Now, when it comes to the second case of common base and common height, the big triangle and the black color shaded triangle, they don't directly have a common height. But if you split the triangle into two portions, okay, for now we are looking at four portions, okay, 1, 2, 3, 4. Within these four triangles, there are triangles that share common height and common base. For instance, if we look at just triangle 1 and 2 from just now, okay, these two triangles, just these two, it has a common height and a common base, okay, and from hence we can actually use the result in part B, and we have found K to be 3/5, so we can shift BC over and get a ratio for the side 3 is to the whole thing 5, which makes this 2. Okay, so even though we cannot directly compare across these two triangles, but we can separately look at the smaller pieces within these triangles and form a ratio. So if we look at OCX and OCB, they have a ratio of 2:5. Okay, now but of course this is not yet the final working in answer because this is not the triangle they're looking for. Okay, so now if you look at the other half of the triangle, okay, if you look at the other half of the triangle, I'm going to use purple, okay, on this side. this is also a triangle that I can find a common height and common base. Okay, so again in this case, because of the hence result from part B, I can say that BX is to BC is 3 is to the whole thing 5, which makes this 2. Okay. So if I look at triangle BCA is to XCA, I will get the entire triangle base, which is 5, and XCA, which is 2. Now the problem with the purple comparison and the black comparison is that you cannot straight away link them directly, because OCB and BCA, even though they share the same number 5, 5, they are not of the same size. Okay, so this one from the diagram you can see it is not the same 5 units. In the purple 5 units and the black 5 units. Okay, so I'm going to now use another color, which is red, to link up these different 5 units. Okay, so if you look at OCB and BCA, although just now we said that they are both 5 units, but they are 5 units to different sites. Okay, so how do we now compare between OCB and BCA? Now, in the first place, we were given this ratio. OC is 3 units, OC is 1 unit, and OA is 3 units. So there is a ratio that we have used in A. Okay. Now, these two red color triangles, they are sharing the same height. Okay, not similar, not the case of the common angle. So again, we will just take the base ratio for comparison of area. Now, if you now look at these 3 different comparison, okay, it means that the 5 units here is actually half of the 5 units over here. So we will now do an overall ratio comparison for all 4 of them that are compatible. Okay, so that in the end we will just be adding the total area to make OAX, and we'll be adding total area to make OAB. So how do we do an overall compatible ratio comparison? So if you think about how these 5 units is in fact only half of the 5 units here, I'm going to make these 2 numbers combine. Okay, so I can say that this is really actually 10 units, and this is 5. Okay, so if you look at BCA and OCB, they are really twice of each other. Okay, so in this case, since this is just 5, that means the 2 is still comparable to the 5. Okay, but because I've made this 10, this is no longer just 2. okay, because I times 2 to this 5, okay, so I times 5 to this 2 so that they are the matchable 10, okay. So when I times 5 to this, I also times 5 to this so that the ratio is fair. That's why this is just 5 units. This is just, okay, I just times 1 here, so this one is times 1. So this is just 2 units. Okay, so here, because I times 2 to make this 10, I must also be fair to this 2. And therefore, XCA is 4 units. Okay, so now, since what we want is OAX, OAX is a combination of OCX and XCA. So I will be adding the non-compatible ratios together. Okay, so to make up OAX, I will add 2 and 4 because we saw them as split triangles. Okay, so now we add them back. And then OAB is the entire triangle which just now we split also. So it was seen separately, but now we can combine. And therefore, we have 6 over 15, but to make it into a simplified fraction, I will divide by 3. Therefore, the answer is 2 over 5.